Welcome back to The Explainer. Today we're taking a hammer to one of the biggest, most persistent myths in AI right now. You've probably heard it. The idea that if we just build a massive, infinite context window, boom, long-term AI reasoning is totally solved. Now, don't get me wrong, it's a super exciting time for AI architecture. But as we're going to see today, just throwing a million tokens at a problem, it's not the magic bullet we think it is. The real solution here isn't infinite attention, it's structured memory.
All right, let's just dive right into this. Here's how we're going to break down true cognitive architecture today. First, we'll look beyond the context window. Then, we'll explore the 5 systems of memory, unpack what's called the energetic paradigm, look into multi-agent shared states, and finally, redefine the context window workspace.
So, Section 1, Beyond the Context Window. Why exactly is just expanding tokens simply not enough?
I really want you to stop and think about this for a second. What actually happens when even 1 million tokens just aren't enough? I mean, sure, a massive context window feels limitless at first, right? You can drop in half a dozen books, a giant software repo, maybe a huge stack of research papers. But in the real world, genuinely long horizon tasks are always going to outgrow any fixed limit you set. Think about running corporate operations over years or conducting deep, multi-year scientific research. No matter how big you make that context window, the task itself is eventually going to get bigger. Let's put this into perspective with a real-world scenario. Say, a long-term scientific project. So the system kicks things off. It defines a research question, forms a few hypotheses, and runs some simulations. Naturally, you hit some walls, explanations get tossed out, and new constraints pop up. But imagine, weeks later, some totally new evidence surfaces that actually supports an earlier hypothesis. To evaluate this properly, the AI doesn't just need the raw facts, it needs the why. Why was it proposed? What were the original assumptions? What failed? You can't just stretch a context window to fix this. Time and new evidence, they demand a fundamentally different approach. And that brings us to Section 2, the 5 systems of memory. Because if we can't just dump everything into one giant text prompt, how do we actually separate the signal from the noise?
See, a truly intelligent system can't just treat its entire history like some messy, undifferentiated junk drawer. It needs structure. Specifically, it needs at least these 5 distinct forms of memory. You've got working memory for the immediate current step, episodic memory to track the history of past actions and failures, then semantic memory for your rock-solid verified facts. Add to that procedural memory for successful workflows and methods, and honestly, most importantly, constraint memory. These are the absolute rules, the safety boundaries, and the hard deadlines that literally cannot be forgotten.
If you just mash all those memory types together, trying to retrieve anything becomes incredibly noisy. Imagine an AI agent designing a complex medical experiment. If it's just searching its memory based on topic similarity, it might grab a note that has matching vocabulary, like random medical terms, but it could completely miss a differently worded note that holds a critical ethical constraint for that exact experiment. That's a huge problem. Memory retrieval absolutely has to be governed by the actual structural need of the task, not just because the words kind of look the same.
All right, let's step into Section 3, the energetic paradigm. We really need to start framing memory as a system of resource allocation.
Now, what's absolutely fascinating here is the stark contrast between simple storage and true memory. Under this energetic paradigm, we have to face facts. An AI agent has finite attention and limited computational energy. It physically cannot light up every piece of stored info at once. Storage, that just preserves information, kind of like a dusty old hard drive in your attic. But memory, real, functional memory, preserves future actionability. A brilliant memory architecture takes that limited computational energy and laser focuses it only on the information that is structurally relevant to the decision being made right now.
Now, you might be sitting there thinking, well, why not just summarize the past? But honestly, summarization alone just doesn't cut it. In fact, it can be pretty dangerous. When you compress information, you're inevitably destroying details, and sometimes those details are vital. Like, if a system summarizes a failed experiment by just logging "hypothesis was unsuccessful," it literally deletes the specific conditions that caused the failure. Fast forward a bit, if those conditions change, the agent might wrongly assume the hypothesis is still a dud. It's like throwing away the instructions just because you built the furniture.
So, instead of relying on naive summarization, a much stronger system uses hierarchical state reconstruction. It builds out multiple layers. At the very top, you have your stable objectives and constraints. Right below that, your current plans and unresolved questions. Further down, you've got verified conclusions, and then finally, right at the base, the raw evidence and detailed records. A smart agent isn't dragging its entire life story into every single prompt.
Instead, it rebuilds the relevant state by moving through these layers based on exactly what the current task needs. It's how you grab exactly what you need, exactly when you need it, with zero overwhelm.
Which perfectly sets up Section 4, multi-agent shared states. And to understand this, we're going to lean heavily on what's called the institutional metaphor.
Think about how a real, functioning human institution actually operates. A company doesn't force one poor employee to memorize the entire corporate history, right? That'd be ridiculous. Instead, they rely on institutional memory. They use records, procedures, specialized roles, escalation paths, and carefully documented decisions. Everybody holds a different piece of the puzzle. Well, AI agent teams can and absolutely should operate the exact same way. You have one agent focused purely on planning, another maintaining the evidence, another tracking the constraints. It's division of labor, but for AI.
Just contrast these two systems for a second. On the left, a weak memory system. You've got one single agent trying to solve, remember, plan, and evaluate the whole shebang all at once. The result? Total chaos. It mixes functions. It essentially rewrites its own memory inside a giant, endless conversation log. It might even treat a total guess as a hard fact later on because it simply forgot its own reasoning. Now look at the strong memory system. Layered memory, highly traceable decisions, and specialized agents actively checking each other's work. The magic here isn't just parallel processing, it's the strict, deliberate separation of responsibilities.
But here's the catch. To make multiple agents coordinate without causing a total train wreck or just duplicating work, they need a shared task state. And no, this state cannot just be a massive sprawling chat log. It has to be built out of structured shared objects. We're talking explicit, highly readable objects, objectives, constraints, backed by concrete claims, evidence, and open questions. Each specialized agent steps in, reads only what it needs, and writes only what's relevant to its specific job. This keeps the uncertainty totally visible and guarantees that big conclusions always stay logically tied to their actual evidence.
All right, that brings us to our final section, the context window workspace. It is time we completely redefine what attention actually means for an AI.
So, here is the real payoff. When you combine structured objects with a proper memory architecture, you get something infinitely more powerful than just a really big context window. You achieve true, unbreakable continuity. The system can stop, resume, delegate, revise, and recover. Think about it. If a long-running agent crashes or gets swapped out after 10 hours of hard work, the task doesn't die. The new agent just tags in, picks up the persistent state, and keeps going, instead of having to read a raw, massive transcript from square one.
I really want to highlight this specific quote directly from the source material because it is a total game changer for how we build AI. The context window is a workspace, not the entire mind. Think about that. Memory is the persistent, structured environment. The active agents, they are just operators, dipping into that environment, doing their work at the workbench, and stepping back.
The system absolutely does not need to hold every single thought in its attention all at once. The real breakthrough in AI architecture isn't infinite attention. Honestly, infinite attention is neither technically realistic nor conceptually necessary. The true breakthrough is finite attention, operating over a persistent, structured, and continuously governed memory. That is the secret to handling tasks where the context literally has no limit.
Which leaves us with one final, pretty massive thought to ponder. If the context window is really just a temporary workspace, how are you going to structure the persistent mind of your next AI agent? Well, that's all for today's Explainer. I really hope this deep dive into structured memory gave you a completely fresh perspective on AI architecture. Keep building, keep structuring, and I will catch you in the next one.